Okay, so we are talking about dilations today. If you remember back a couple of chapters ago, we talked about different types of transformations. We talked about deflection, the rotation, and translation. And those are all rigid motion. Remember what rigid motion is? Nothing changes. The size of the shape doesn't change, just the place. Okay. And so that was those are rigid motion. Now look at this picture right here. Roosevelt High School sells a sticker and a larger car decal with the school logo. Look for relationships. How are the sticker and the car decal alike? How are they different? Okay, the angle measures looks to be the same, right? Okay. What'd you say? They're smaller, okay? The angle measures are still the same, which means they're smaller. So what does that tell you about the segments themselves? They're smaller, right? But they still hold the same shape. So what do you think that might mean? All the angles would have to stay the same. And if the sides, if it still appears to be the same shape with the angles being the same, then more than likely the sides are proportional. Okay, and that's what we're going to talk about today. Okay, because and what that is a picture of a dilation. Suppose the sticker and the decal are shown next to each other on a computer screen. If you zoom in to 125%, what would stay the same in the figure? I said it, the angle measures. And what would be different? The side lengths, right? So, technically, when you're on the computer and you zoom in or out, okay, they basically, stay the same. Okay? But like, when a lot of times I cut and paste onto your notes and onto your assignment, I have to be careful how I reduce or enlarge, because if I do something like this, let me do another one. Okay, if I put this one in here, let's say I do that. When I shrink it or enlarge it, it distorts it, right? That's not considered a dilation, okay? So by definition, a dilation is a transformation that enlarges or reduces the original figure proportionally. A dilation is what's called a similarity transformation, okay? What we did earlier were congruence transformations, which they were rigid motion. You can use rigid motion, but it has to be together with a dilation, okay? And technically, really, when you dilate something, there is some rigid motion because it moves it somewhere, but then it shrinks it or enlarges it. This is the notation that we use for dilation. We use the letter D, and then in parentheses, as a subscript, down below, this letter N here is the scale factor. And this letter C is the center of dilation. Yes?
Oh yeah, apparently.
Yes. Okay. The center of dilation is the fixed point from which the dilation is performed. When I was showing you that one when I was making it bigger or smaller, that would be that point. The scale factor, which is represented by that letter N, is a ratio of the image length to the pre-image. What's the difference between the pre-image and the image? Do you remember? Pre-image is the shape before the transformation. The image is the shape after. Okay? So to find scale factor, it's always image over pre-image. Okay? Image over pre-image. And it must be simplified as a fraction. Okay? So image over pre-image. Okay, so here's an example of a couple of dilations. This one right here is a dilation with a scale factor of 3 from point P. Okay? And so what that tells me is that is this an enlargement or a reduction? Can you tell? It is an enlargement, right? Okay, and you're going to learn that anytime your scale factor is greater than 1, it's an enlargement. If it's between 0 and 1, then it's a reduction. Okay? Alright. Now, when you find scale factor, you can do it really in two ways. You can use the side lengths, or you can use the distance from the center of dilation. So let's say I told you that this length AP was 6, and I wanted to know this length right here. What would I do? Because this is telling me that the enlargement is 3 times as big. You times it by 3. So then this right here would be 18. Okay. We went back, and let's say we didn't know what the scale factor was, but we knew that this length was 18 and this was 6. We would set up a fraction, image over pre-image, and that's where they got the 3. Okay? This right here is a reduction, as you can see. Because look at, there's a D prime, so it gets smaller. Now, I used the wrong letter right here. This should be a 6. Let's change that to a 6. Okay. This is a dilation with a scale factor of 1/3, and the center of dilation is C. Okay. Now again, anytime you have a reduction, your scale factor is going to be a number between 0 and 1. Okay. So let's say that this distance here, CP, is 6. Right? I want to know CP prime. What's this distance right here? Okay. It's 2. Alright. What did you do to get that? Alright. Okay. So 1/3 times 6, or 6 divided by 3. Okay. Good. And again, let's say we didn't know that and we were looking for the scale factor, we would do image over pre-image, which reduces to the 1/3. Because it's between 0 and 1, we know that it's a reduction. Okay, determine whether each dilation is a reduction or an enlargement and find the scale factor. Now, up here, to figure out the scale factor, or when we worked with it, we went from the center of dilation to each one of the points. You can also use the length of the sides. Okay, so determine whether each dilation is a reduction or an enlargement and find the scale factor. So my blue is my ABC, and my green is my A prime, B prime, C prime. Is this going to be a reduction or an enlargement? Okay, it is an enlargement. So what does that tell me about the scale factor? It's going to be more than 1. Okay, so I need to pick and count the distance. Now, if I'm going to use the shape, obviously you want to choose something that's horizontal or vertical. If you use one of the diagonals, you have to use the distance formula to actually find the length. We don't want to do that unless we have to, right? So if you can use a horizontal or a vertical line, you can just count. So if I count this, it's 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? And so we said that this was an enlargement. Okay? And so what, how do we find the scale factor? 16 over 8. Okay, it's image over pre-image, which means the scale factor is the 2. Okay, what about this one? Is this an enlargement or reduction? This one's a reduction, right? Okay, so I'm going to use my horizontal lengths here. This is 1, 2, 3, 4. And this is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay, so what would my scale factor be? 4 over 6. 7. Okay, because my scale factor has to be between 0 and 1. Okay. Rectangle W prime, X prime, Y prime, Z prime is a dilation with a center P of W, X, Y, Z. How are the side lengths and angle measures of the two figures related? Well, what do we know about the angle measures? They're all the same. They're what? They're 90-degree angles, aren't they? Smooth tell because of the graphic. Okay, so the angle measures are the same. Okay? How are the side lengths and angle measures related? So what do we notice about the side lengths? If I look at this right here, it's 2. This is 1, 2, 3, 4, 5, 6. This is 1, and this is 3. the scale factor would be 1/3 because you go image over preimage. Because if I took 2 over 6, that equals 1/3, right? If I did 1 over 3, that's also 1/3. So the sides are proportional, right? So how are the side lengths and how the side lengths related? They're proportional. So side okay, so side lengths are proportional. You know what it means that when I say something's proportional? It's consistently shrinking down, right? So when you compare one to the other, they reduce to be the same amount, right? They both reduce to be 1/3. Now, remember, we said that you can compare the side lengths, but you also should be able to compare their distance from the center of dilation. So if let's say I go use Z and Z prime, okay? Z prime is 2 units from the center of dilation, and Z is 1, 2, 3, 4, 5, 6 units, right? That's still 1/3. Okay, so whether you look at the side lengths or their distance from the center of dilation, they should all be the same ratio. Okay, dilate a figure with the center at the origin. Okay, so let's talk about some ordered pairs here. Okay, we're going to talk about how to do it from the origin. You can also do it from another point on the coordinate plane, but we're just going to worry with the origin right now. What are the vertices of a dilation with a scale factor of 3? Now, when it shows it to you like this, that indicates that the center of dilation is the origin. Remember, in the other problems, it was a subscript with the scale factor as the first number, and the second number was the center of dilation. When there's nothing there, then that indicates the center of dilation is the origin. Okay, so this one has a scale factor of 3. So what you do when you have your ordered pairs is basically you just multiply the ordered pairs by what the scale factor is. Okay, so I'm going to multiply through each one of those ordered pairs by 3. So that means A prime is going to be what? 6, negative 3. What's B prime going to be? Negative 3, 6. And then C prime is going to be 9, 0. Okay? This one is, what are the vertices of a dilation with a scale factor of 1/4? What do you think you're going to do here? You're going to divide or multiply by the 4, which is the same thing as dividing by 4, right? Okay, so P prime would be what? 2, 1. Q prime would be 3, negative 1. And then R prime is negative 1, 0. Now let's graph that one. See, P prime is at 2, 1. Q prime is at 3, negative 1. And R prime is at negative 1, 0. So if I drew that, you can see that it's a reduction, right? Okay. Now, again, remember, I can compare the side lengths. None of these are horizontal or vertical, so it'd be a little bit hard. But in this case, I might want to compare their distance to the origin. So, like, R prime's distance from the origin is what? 1. And R is 4. So again, we get that scale factor of 1 to 4. Okay, we're looking at that distance. That's the next question. How are the distances to the origin from each image point related to the distance to the origin from each corresponding pre-image point? Okay, it still has the same scale factor. Okay, so you could write that. Okay, so let's apply this. A blueprint for a new library uses a scale factor of 1 to 50. Mr. Ayer measures the reading space on the blueprint to find the actual dimensions and area so that he can order furniture. What are the actual dimensions of the reading space? It's kind of hard to see, but this width here is 14. Okay, and this length here is 12. And it's in centimeters, okay? So I want to find what the actual dimensions were if it were to be built. Okay, and the scale factor is 1 to 50. 1 representing, the blueprint in centimeters. So 1 to 50. Okay, so how would I set that up? I would take 1 is to 50 as 14 is to x. We don't know what that is. Okay, so we would do 1 is to 50 as 14 is to x. And we would do the same thing with the other dimension. And we can do 12 is to y. Okay, so then if I cross multiply 50 times 14, 400. What is it? 700, that's what I thought. And this is 700 centimeters. Okay? But if I were going to go and talk to you about what I was going to put in your home as far as furniture was concerned, would I say 700 centimeters? No, what would I say? Well, okay, let's say we lived in Germany. What would I say? Then I would do it in meters, okay? So how can I change that? Just convert it to meters. What would it be? 7. Okay. Same thing here. I would cross multiply. I end up with y equals 600, which is 6 meters. What would the area of that space be? 42 meters squared, right? All right. Okay, let's look at this next one. Here's a different problem. This time you have a blueprint for a house using a scale factor of 1 to 20. If the dimensions of the actual kitchen are 3.1 meters by 3.4 meters, what are the dimensions of the kitchen on the blueprint? How would I do this differently? Because my scale factor is 1 to 20, and if I took the first dimension, what would I do? Now 3.1 is the actual dimension. Well, you would just flip it. Instead of being 3.1 over x, it would be x over 3.1. And so then we would cross multiply. 3.1 equals 20x. And 3.1 divided by 20, that would be 0.155 meters, right? But that would be hard to measure on a blueprint, so what should I do? Convert it to centimeters, and what would that be? 15.5 centimeters, right? Okay, so then we would do the same thing for the other dimension. 1 is to 20 as y is to 3.4. We end up with 3.4 equals 20y, which is 0.17 meters, which is what? 17 centimeters. Alright, here's one more. Christine created a decal from the Owasso Rams logo. Is the decal a dilation of the original logo? If so, what is the scale factor? Okay, what am I going to have to do to determine if this is the dilation? It appears the angles are the same, right? Okay, but what do I need to look at? See if they're proportional. So I need to compare the dimensions, right? So if I took 5.4 to 2.7, if it's proportional, then I should be able to take 15.6 to 7.8, right? Okay, so how can I determine if they're proportional? Okay, if we simplified it, they both reduce to 2, so that would tell me that it's proportional. What's the other thing I could do? I could cross multiply, that would work also, like we did yesterday. And if I get 42.12 for both, which I will, then that's proportional. Okay? So the answer is yes, it's a dilation. Now I want the scale factor. Is this a reduction or an enlargement? So what do we know about the scale factor? It's going to be less than 1, between 0 and 1, right? Okay? So how am I going to do that? You're right. Okay, you're right. We'll say some freaky number. I mean, what's the thought process that goes into it? You said 5.4 over 2.7. Would that be right? No, because what has to go on top when you figure scale factor? The image over the pre-image, right? So instead of what he said, there would be 2.7 over 5.4, which is right. It doesn't always, work out to be a perfect. Sometimes it's 4/7 or 8/9 or something along those lines. Okay. Also, one thing I do want to point out is if you didn't recognize this as 1/2, could I move the decimal over on both of those? It's like multiplying the top and the bottom by 10. It's like it's like a 1, 10 over 10 to 1. So I could have done that and gotten 27 over 54, and then 27 goes into both of those. Okay, that's just kind of nice math. All right, any questions? Okay, so your assignment today is on Math Excel. There's 2 different ones that you need to do. There's one that says additional practice, and then there's one that says like practice or something like that. There's only 10 questions on both. Okay, so it's not real long. I just couldn't find a lot of questions, on one or the other. So